Hey developers, this is Riddham and today we are going to build a decentralized savings circle pool dApp on top of Rootstock blockchain. Think of it as a traditional savings club, but this time with Rootstock's security. You know how savings group works back in time? Friends pool together money and each cycle one person gets the whole amount of the pool. It's been done for generations and decades worldwide. It's been known by names such as Stitfund, Tandas, Susus, and many. The main problem here is we need to trust the people here. We need to trust the organizer. We need to trust the contributors. We need to trust the process here. So that's why we are building it on chain to solve this problem. No middleman, no trust required, just transparent and fluent system. Here's what we are going to build today. We'll firstly be creating a smart contract with custom savings pool and with targets and recipients. Thereafter, we will contribute RBTC through wallet connections and transactions. Thereafter, we'll have real-time progress tracking. And lastly, automatic fund distribution with targets and recipients. Okay, after that, we are building this on top of the Rootstock blockchain, which is involved with Bitcoin security, with the OG power of Ethereum's developer tools. By the end of this tutorial, you'll master the Rootstock blockchain architecture, its smart contracts, and the VM technology. You'll also be able to get to React Frontend with TypeScript and Wagmi, and a proper end-to-end dApp deployment. But the prerequisites before going into this session, you'll need our basic Solidity and JavaScript knowledge, the Node.js v18 plus, and lastly VS Code and MetaMask installed. And the most amazing thing is everything's on GitHub. The link is in description. You can get all the resources. You just need to clone it, and it will be able to run. Before we even write a single line of code, let's talk about why we chose the Rootstock blockchain for this project. Understanding the why will eventually make the how so much more meaningful. Rootstock, also called RSK, is a smart contract platform that does something really clever. It's merge mined with Bitcoin and is fully EVM compatible. Let me break this down what that actually means and why you should really care about this. The Bitcoin is the most secure, most decentralized, most trusted blockchain in the world right now. It has over 60% of the entire crypto market cap. But Bitcoin can't run smart contracts. We all know that. You can't build DeFi, NFTs, or dApps directly on top of the Bitcoin blockchain. That's a massive limitation. On the other hand, Ethereum has smart contracts and a thriving dApp ecosystem. But it does lack something. It doesn't have Bitcoin's like security or its massive user base. And let's be honest, most Bitcoin holders are hesitant to jump onto other chains, right? Rootstock bridges these two worlds. Here's how. First concept is merge mining. Rootstock is secured by Bitcoin miners. The same miners that secure Bitcoins are simultaneously securing the Rootstock blockchain. This means Rootstock inherits Bitcoin's hash rate, the most powerful computing network on the earth. Your smart contracts get Bitcoin level security. That's a huge point. Secondly, there is EVM compatibility. You can integrate your smart contracts directly onto Rootstock without any changes from the other EVM compatible chains. You can use tools like Hardhat, Remix, Truffle. They all work. Same wallets, MetaMask works out of the box. Zero learning curve for Ethereum developers. Thirdly, RBTC. The native currency on Rootstock is RBTC, which is backed one-on-one with Bitcoin. You convert BTC to RBTC and you can always convert it back freely. This brings Bitcoin's liquidity and Bitcoin holders direct access to the DeFi ecosystem and dApps on top of the blockchain. But why this matters for ARDA? Think about what we are building. Okay, we are building a savings level pool where people pool their real monies. So the concept here is security. It isn't optional here. It is mandatory. With Rootstock, we can get Bitcoin proven security for protecting users' fund, familiar Ethereum development tools that we already knew, access to Bitcoin holders who want to use their BTC productivity. For a financial application like ours, Rootstock is the perfect platform. We're not compromising on security, but we are building the next gen secure platform. All right, that's enough of theory. Now let's get our hand dirty and start building. First of all, we need to open our browser, and in it, we are gonna add the testnet configuration in our MetaMask wallet. You can just open the MetaMask wallet, and as you can see right now, my network is set to base mainnet, but we need the Rootstock testnet network. So I'll just go ahead and type Rootstock testnet chain list. Okay. Here we have the Rootstock testnet RPC. With the chain list, we can directly add the testnet to our wallet. We just don't need to put manual configurations. We'll just hit connect wallet. Once connect, we'll just say add to MetaMask. Okay, and we'll just approve this. Once approved, now we need to get the faucet, basically the RBTC tokens to initiate transactions, deploy contracts, and those stuff. So we'll just head over to faucet.rootstock.io. And here, we'll just copy our wallet address, paste it here, and just press I'm not a robot, as I seems not to be, and then just get test RBTC. It takes 30 seconds to perform a transaction on Rootstock blockchain, basically, because it's merge mining from the Bitcoin nodes. We have got the Rootstock network in our MetaMask. Okay, so finally our transaction is successful, and if we check our wallet, we should have got the TRBTC tokens. I'm not seeing them. We'll just go to the transaction hash. Okay, MetaMask was unable to show that. Now we have got our TRBTC. Now what we'll do is we'll just head over to our smart contract development. What we can do is then simply just go to the github.com/Riddham and go to my GitHub profile. And here I have put it the saving circle rootstock tutorial. It has two branches, one is base and another one is final. If you want to build, you can just clone the base branch, and if you just want to skip this and go to the final part, you can just go to the final branch and check out its functionalities and all. Okay, so let's just go ahead. I'll just make a directory called rootstock cd into rootstock, and here we'll get clone our project. Was clone successful. Okay guys, so here we have our saving circle rootstock folder, and this is basically our project directory. Now, what we need to do is we just need to press right click and open it with the cursor. Okay, so here you can see our project directory is open. We have two folders. First is backend smart contract, and another one is frontend. In backend, we have defined the hardhead directory, hardhead project structure, which have hardhead.config.ts, contracts, ignition scripts. If we want to write a contract, we need to do it here in contract counter.sol and have our types in here. Okay, we can write deploy scripts in the scripts folder. And our frontend is of Next.js kind with TypeScript, Wagmi, and Veeam. We are gonna be interacting with our frontend to smart contracts, and it's gonna be awesome, stylish frontend. So now, in order to manage our smart contracts, here we are going to use Remix as it is mostly accessible with everyone, and we do not have to put our private key in the .env file too. So we'll just go ahead to remix.ethereum. Remix is basically the well-known online IDE. It's officially by ethereum.org. Okay. So we'll just create a new workspace here. We'll just create a new blank workspace, name it as Rootstock Savings Circle, just right like this. Now I'll just create a new file named as saving circle, my bad, saving circle dot sol. Now this is basically an empty smart contract file, and remix.sol is basically the file extension of Solidity. Now I'll just paste in our smart contract, which I've already written, because if I have to write, it's going to be a really, really long tutorial. So what we're going to do is we're going to deeply walk through with all the data structures, functions, and everything in the smart contract. So without wasting any further time, let's get started. So let's just dive into our smart contract. First of all, in line 1, we have the SPDX license identifier, which is basically the license of open source, that is MIT, which we need to specify in every smart contract. Okay. Thereafter, we have the Pragma Solidity version, which version of Solidity we are using here. The caret symbol basically specifies that we are going to use the greater function or equal to function than the specified, like 0.8.20 and greater. Okay. Now, for defining a contract, we need to use the contract keyword followed by the contract name. Conventionally, the first letter is capital. Okay, now here's the real part. The real fun begins from here. First of all, we have the structure data type, in which we basically define all of the structure we need to put. It's basically kind of a custom data type we can define, okay? So, first of all, we have ID, which is basically unsigned integer of 256 bits. Thereafter, we have a string kind of name and description, followed by address. Address is basically the rootstock address, that is this. Okay. Thereafter, we have the contribution amount, total cycles, current cycle, cycle duration, last cycle time, all of the data types which we need in order to complete the smart contract. Thereafter, we have booleans, whether the cycle is active or not, what is active or not, it is completed or not. Thereafter, we have the created at timestamp. Thereafter, we have the array of winners and members. This is basically a lot of data. So we are taking almost every part of data in order to select and put the bot configurations. Thereafter, we have the cycle info structure, which have cycle number, total collected, and address of winner, completed at uncertain integer, and boolean is the cycle completed or not. Okay, so these were our structures. Now we have a private variable which is basically is the pot count. We are going to need this a lot in order to specify the pot ID. Okay. Thereafter, we have some key data structures known as mapping. Mapping is like one-on-one data type. We can assign any uint to another data type, any address to another data type, like that. Okay, first of all, we have the pots mapping, which basically signifies a relationship between the uint and the pot structure, which we defined earlier. Thereafter, we have is member, has paid cycle mapping. This mapping just tell whether the member is registered or not, has paid the cycles or not. We have private cycle collections. It's just mappings to store the collection of cycle and cycle history. Thereafter, we have events. Events are basically the situations which are called when the function is completed. These are basically used to track that this function took place at this time with these inputs. Okay, we can basically emit the events when the function is completed or when we need it. Okay, it's basically used to keep a track of data. We have pod created event, we have member joined event, we have cycle contribution event, we have cycle completed event, and whether the pod is completed or not event too. Thereafter, we have a modifier, the pot exists. Modifier is basically a checking function, the checker function, which basically checks whether the condition is met or not. If the condition is met, then it lets the function to implement, or not, it falls into another situation. Now, we have our very first writable function. Writable function is basically a function which initiates a transaction onto the chain, in which we are basically interacting and writing to the blockchain itself. We have our create pod function, which basically takes 5 parameters: name, description, contribution amount, and cycle duration. In the string bar of function parameter, we need to specify the basically the storage, whether it will be a memory, storage, or those kinds of things. Okay, this is basically an external type of function which returns inside an integer. We are just checking the conditions with required keyword, whether the contribution amount is greater than 0, the total cycles are greater than 1, the total cycles are lesser than or equal to 24. Now, these are the met situations which we have defined. Those should be met in order to implement the function. Now, we are just pushing all of the data which is given to our pods mapping. Okay, which is just configuring all of the data like name, description, creator, contribution amount, total cycle, and all of that. And last, we are just pushing that whoever creates that automatically joins the pool too, and we are just setting the member status true. And thereafter, we are emitting the events which we created earlier: pod created, member joined. Okay. Now, once the pod is created, the other members will be able to join the pod. Okay, so here we have the function of join pod, which is also an external function. That means it can be callable from external sources. Now it have the modifier exists, whether the pot exists or not. We had specified a modifier that basically checks with the pot ID whether the pot is active or not. Okay, now what it's doing is it's just specifying a new storage pot, and then it's just checking with the requirements and setting the member status of the joinee to be true, and everything that events that member has joined the pool. Now we have the contribute to current cycle function, which basically takes in pot ID as its parameter. It's also an external function. Now the different thing is it's a payable function. Basically, this function allows user to contribute the amount, basically the pool amount, to the smart contract. So that's why it's a payable function, which means user can transfer the amount to this from via this function. Okay, we are just using the modifier again. Then we are accessing the pot structure, and we are just checking out the request statements. And lastly, we are setting out the status of payment to true and marking it in the cycle collections too. And thereafter, we are just emitting the cycle contribution event that we had created earlier. Okay, now we have our complete cycle function, which is also an external function. And this also takes pot ID as its parameter. We are doing all operations by pot ID. It is our main, what we say, it's our main differentiator. It's our main callable value from which we can access pods. Okay, we are here also using the pods mapping to create a new stent of it. Now we are just creating a current cycle unsigned integer and then assigning the pod dot current cycle value to it. Thereafter, we are checking if all of the members have paid for the cycle or not. We are using the members list in the loop and checking whether they have paid or not. Okay, now we are just checking if minimum cycle duration has passed and who are the eligible members. We have defined this get eligible members down below. Okay, now lastly, we are drawing our winner. This is how we are doing is we are just accessing the Kajik 256 algorithm and encoding it and defining our inputs, and thereafter it will give us a random winner. Now we have the winner address. We are just defining it in the eligible winners list. Thereafter, we are just specifying the price amount of cycle collections with pod ID and current cycle. Now, though we have the winner, we are just pushing it to the array of winners. We are just pushing it to the list of the winners. Thereafter, we are storing it in the cycle history. At the very last, we are just transferring the price through the transfer. We are just transferring the price of the winner. We are using this kind of statement for here. We are just making the winner payable and pushing the value of price amount to it. Okay, and we are just emitting the cycle completed event and moving out to the next cycle or checking whether a spot is completed or not. Okay, thereafter we have the get eligible members function, which is basically a view function. These were our write table functions. These are view functions, which doesn't take any gas to execute. Okay, these are basically callable functions, which calls blockchain data and showcases and gets it to us. Okay, here we are just getting the list of eligible members, which we are using in as specified upper function to get all the eligible members. Now we have some more view functions, which are get pot to get a single pot and its data, and we have get members to get the members involved in the pot, to get winners of the pot, cycle info, the specific cycle info which we need to know of each pot. Okay, we have has member cycle, member paid cycle function, the basic functions which just basically get the data out of the state of blockchain. Okay, we have get cycle progress. We have the is member of, which basically define whether the address is member of the pot or not. We have get total pools, which is basically a uint return function which counts the total pots. Can complete cycle or not. Okay, these are some basic functions. At last, we have receive and fallback function. If anything goes wrong, these functions are called. Okay, now this was our whole smart contract. Okay, we have gone deeply into it, what it's doing, how it's doing, and how certainly we can make it and create it. Now you should be able to create a basic smart contract. You should try to write it by your own using different methods, different functions. Okay. Now, what we need to do is compile the smart contract, check out if there's not any error. Basically, there's not. So we'll just press Control S, and as you can see, a green tick says it's successfully compiled. Now, we need to switch to the environment, that is browser extension, our MetaMask. Okay, so this is basically our wallet. And the good thing about it is it just automatically verifies the contract by itself onto the Explorer too. So I'll just hit deploy and verify and just confirm the transaction. It basically takes 30 seconds in order to deploy the smart contract to the Rootstock blockchain. Okay, guys, so as you can see, our contract is successfully deployed here. We can just interact with it directly in here using the remix inbuilt testing functionalities. We have the complete cycle, contribute to the current cycle, create pod, and here's functions that we define in the whole smart contract. Okay, so from here we have got the contract address, which we can copy, and here in the Solidity compiler we have the contract ABI and bytecode for interacting with a blockchain on the front end. So here's our front end code. This is basically the final branch. Okay, here we have our app, we have components, we have config, contract, hooks, library, node modules, public, and Next.js, all of the folders. What specifically of Web3 we have is we have the components providers, we have the wallet provider.tsx. Thereafter, in config, we have the configuration of contract, and we have the ABI, which we can, as told, easily get from the Solidity compiler through the ABI option. Okay, and we can easily get the address from here. Thereafter, we have hooks. This hook is going to be very useful for us to interact with the front end to the back end. Okay, in this, we have defined all the functions. Those are required in order to, interact with the smart contract. Yeah, that's the backend part of Web3. We have got our libraries, public folder, and package.json in which all the libraries with the versions are listed. Okay, now let's check whether our dependencies have been installed. Okay, so now what we can do is we can just hit npm run dev. Okay, it's active. Now, first of all, let's just go through the code line by line and understand what it basically does so that we can make it ourselves. Okay, first of all, we need to head to providers, which basically sets up a wallet connection between the MetaMask and okay. Now in this wallet provider, first of all, we are importing create config http Wagmi provider from Wagmi. Okay, thereafter we are importing query client and query client provider from the query. That's normal. Thereafter we are importing injected from Wagmi connectors. After that, we need to provide some configuration of the Rootstock chain. Its ID, name, native currency, RPC URL, and block explorer. you need to put correct RPC URL and chain ID in order to interact with the same chain. Thereafter, we are just putting it into the create config parameter, and then we are just making SSR, a source side rendering true, and giving transports to rootstock chain.id and its RPC basically. Thereafter, we are creating a query client of the same entry and passing it through the child component. Okay, this is our wallet provider. Now we need to pass this wallet provider in our layout.tsx file, in which we have basically imported wallet provider first and then just put it as a component. And inside it we have a child component, which is our whole tab. Okay, now we have got the wallet connection. Now we need to showcase it in the navbar basically. So we'll head to navbar, and here we have defined some const which basically use account, use connect, and use disconnect and use state hooks. Okay, and it basically handles wallet connection and disconnection. Okay, now there is this wallet connect button on which the function is triggered and the wallet is simply connected. Okay, thereafter, once our wallet is connected, what comes next is using the smart contract which we made. So we just pasted the ABI, and now we just need to use it into our hooks. Okay, now for interacting with wallet, we need just three things: signer, the basically contact address, and lastly ABI. We have got ABI address and signer basically from the wallet connection which we did. Now we can easily interact with the functions. First of all, in hooks, we have imported some functionalities of use read contact, which basically calls the view functions, and use write contact, which calls the write table functions, the transactions, and use wait for transaction received, that just generates the transaction received from Wagmi. Okay, thereafter we have got pass ether from Veeam, that is just for decimal values we are using in RBTC. Okay, now we are using use total paths. We are using the use read contract hook and passing the required parameters to basically get the functions. Here we are calling basically all of the view functions to here, the use winners. It's pretty normal. We are just passing out the arguments and function name, and then we have our write hooks. Okay, write hooks use write contract. Okay, now in this we are just passing out all the functions in a very correct manner. Okay, calling the write contract, which is basically returning the receipt and data. Okay, that's about the hook and how we can interact with it. In the same manner, we are importing it. We are implementing the functionalities of the smart contract into the front end. As you can see in our create pool, we are firstly checking whether the user is connected to the wallet or not. Thereafter, we have the data is loading success variables, and then we have total pods before, which is basically using the hook that we defined, and it automatically calls it and showcases in the front end how much total pods are there. Okay, you can set form data, and that's the things. Now we have some more functions, and thereafter we have handle submit, which basically formats data into the corrected manner. Thereafter calls the create pod function, which basically goes and just go to the hook and calls the function from our smart contract. Okay, once it's confirmed, it's just logs in the receipt and just push the router to the pool that we just created. Okay, this is how this all works. This is just some normal TypeScript and JavaScript and some HTML components. That's just Next.js part. Okay. Now in the IDs, we have the same kind of manner of implementation. We are first of all checking is user connected to the account, to the MetaMask basically. Thereafter, we are checking is the cycle completed, what's the status, transaction received. Okay, we are checking handle join pool, and it just calls the join pod along with pod ID. And thereafter, handle contribution, handle complete cycle. All of those functions are stated in a normal JavaScript calling manner. Thereafter, we have our main page, which basically showcases the data as we discussed earlier. So you're good to go. Now we can just move here onto our local host port 3000 as it says. We just wait till it loads, and here's our good front end. As we can see, I have created some pools from the remix ID before, and 3 pools, active savings, these are just random numbers, okay? And all on Rootstock Testnet. Okay, we can create our pool. Let's just go ahead and do that. First of all, let me check is wallet connected to the right one. We'll just connect it and switch to our Rootstock Testnet, okay? Now, we can just create a new pool. Here, we can describe the new pool to, let's say, animal charity and resources. This pool is specifically designed for orgs looking for I'm a charity support, anything random. Okay, now we are making it as a goal based. Okay, open pool. We are supposed setting target to $2,000. Select duration. I'll just put some random inputs. Now we can just put optional rules if you want. I agree to the pool terms and conditions. Create the pool, and I just stuck with the MetaMask pop-up. Here is our transaction. As you can see, I can hit confirm, and we'll just wait for the transaction to be confirmed. And once our transaction is confirmed, yes, it's confirmed, we can, we will be redirected to this page that is Animality and Resources that we just built with the initial funding, target, and remaining. We have 6 cycles. We can add contributions from here. Okay, we have a create pool section. We have all of the pools, and as you can see, it's not listed right here. Okay, I just hit reload, and as you can see, our animal charity and the sources pool is right here. So we can just hit join pool. We can go to view details and get the details. Okay, of course I can't, contribute right now because I don't have that much balance in my faucet. Okay, and we can easily contribute each month. One pot member will be selected and everything will be shown here in the dashboard. Here we have all the pools that I created earlier too. Okay, so that is our whole project. We have created a whole saving circle project from beginning to end. And we are basically done with our whole end-to-end dApp. Look at what you have built. It was a complete dApp. We have gone through each line of code in it, running on Rootstock Testnet with Bitcoin's ultimate security. You have smart contracts handling with real value transfers, a modern Next.js frontend, seamless wallet integration, MetaMask connection, and a very prediction-ready smart contract with its architecture. Today, you guys have mastered Rootstock architecture with power packing and merge mining, smart contract development with Hardhat and Veeam, professional testing patterns, React, TypeScript, Wagmi interactions, basically full stack blockchain development. This is real professional blockchain development. But in order to make contracts and front ends by your own, you need a lot of practice. You need to make projects. You need to participate in hackathons, competitions. Okay, you need to be consistent on your work. That's why I am leaving you a challenge. Implement a vote to release feature where participants can vote which month to which recipients the fund shall be distributed. Basically, you can add a bidding mechanism, you can add a voting mechanism, you can implement 60-75% approval threshold, a time window for bidding or voting. You can emit those events in the updated UI, you can handle those edge cases. All starter code hints are in the GitHub repo. Go explore yourself. Everything is top notch with top quality. Deploy your enhanced version of this dApp with the contact address in the comments. Or if you want to go and build more complex applications, you shall build automated market makers, multi-pool management dashboards, recurring contributions with automations, mobile apps that are being, kind of trendy right now with blockchain. You can build some decentralized identity systems. And that was it, guys. At last, some of my thoughts just to help you code in the blockchain space. It's not just about code every time. It's about building systems that give people control. Saving circles have helped millions build financial stability. By bringing this on-chain, we are making it accessible and trustworthy, okay? Rootstock is underutilized, which means massive opportunities for builders like you, and there's much less competition. Rootstock is just awesome and too much secured. Don't just watch tutorials, you just build yourself, experiment, and deploy, iterate as much as you can, and that's how you grow and ship as fast as you can. Thanks for coding with me today, guys. It was awesome. Drop your contact addresses below. I'm excited to see what you create. Keep building, keep learning, keep pushing the boundaries. Happy coding. See you next time.